Good afternoon, students. Welcome back to Mr. Chen's YouTube channel, the Pre-Cal Masterclass. So this one, just want to talk about that 8.4 today. So this one, 6.3, Vector in Plane. It's the same as section 8.4, Vector. So let's talk about vectors for the introductions. So vector in geometry is called a ray. If you do recognize the ray, so it shows like initial point, and then there's no end point, but it shows the direction. Okay, like that. So let's say that we do have one of the examples like point A, x1, y1, and then point B, x2, y2. So in order to find out this ray or the vector, so this one is called vector u or vector AB or the ray AB. So this one from the tail, the initial position. So the tail is always called the initial position. Okay, so let me just spell that. Initial positions to the final position. To the final position, so or the head, and then the initial position is called the tail. Final position. Okay, so from the initial to the final position. So anytime they deal with the vector, so it shows that not just the direction, okay, the direction, but also it shows that the magnitude, and that's something we talk about for the previous polar coordinate. Okay, so magnitude and then the direction. So the length of the vector is called the magnitude. Okay, so always the length. So if you see that the norm, okay, the double line like that, it's like people are saying that's like absolute value of absolute value. No, it's not true. It's called the magnitude, or it's called the norm. So the norm of vector u, so that one is just like consider square root of a plus b. So this one with the xy coordinate form, subtract to get the distance, and also you can say that it's the xy or the AB component form, or this one could be written as the IJ component form. Okay, so this one is called the AB component form. So this one is called the IJ component form. And the direction of the vector is theta in standard position, so theta. So let's say this one is like a horizon, so theta, then that'll be this angle. Okay, so in standard positions, so standard position means that between 0 and 360 degree, or 0 and 2 pi radian. Okay, so now let's take a look at that, the following. So 2 times vector u, so vector u is given like that. So 2 times, so that means we just need to extend this vector. So it's going to be twice as long as the original one. So extend it all the way from the initial. Then here's another one. So basically just 2u, so u, here's another u, so 2u. And then 1/3 of vector u, so 1/3, that means just want to cut this vector into 3 parts, trisect it, 3 parts. So over here, so that's 1/3 vector u. And then negative vector u, so vector u is going this way to this, all the way to the second quadrant. So this one negative, so just like the polar coordinate, opposite, it's a reflection. Okay, so negative vector u. Okay, so now let's see what else that we got for the rest of this. So the vector u contains the initial point, -4, 3. So -4, 3, quadrant 2, initial point, so the tail. And then the terminal point, 1, 1, right up here. So once you connect it from the tail to the head, so it's going down this way. And then find its component form and its standard form. Okay, component form, that means just like AB. And then standard form, then that'll be considered AI plus BJ. Okay, so make sure that you know the difference. Component form, standard form. So component form, what we need to do, so it's always the terminal point minus the initial point. So this one is just using that x2 minus x1, and then y2 minus y1. So for the component form, so x2 minus x1, so 1 minus -4, and then comma, 1 minus 3. So what we found here, it's 5, comma, -2. And then standard form is written as 5i minus 2j. Okay, so for that vector, so let's say this one is vector u. Okay, so one is considered the component form, the other one is the standard form. Okay, so in order to sketch the graph, sketch the point and sketch the vector in the standard form, so that means started at the initial 0, 0. So 5 units to the right, down 2. So going to the same direction. So you probably see that this one is 2 line segments or 2 rays, they're parallel. Indeed, they're parallel. This one is supposed to be like straight. Mine is a little bit curvy. Okay, so let me just resketch that one. So this one connected. Straight. Okay, so if you try to connect those dots here, so it's kind of like a parallelogram. So this 2 ray right here is supposed to be parallel. And also find its magnitude and direction. So the way to find out the magnitude, so we basically take the norm of vector u using the Pythagorean theorem, 5 square, square root of 5 square plus -2 quantity square. So root 25 plus 4, so it's root 29. And then in order to get the angle, so we take the inverse of tangent of b over a. So inverse of tangent of -2 over 5. Okay, so using that. And we do know that the angle is going this way, so it's going to be in quadrant 4. Okay, all that. So using the calculator, we'll see that it's inverse of tangent. Second, inverse of tangent of -2 over 5. So the one that's given here is just the reference angle, so negative because that's in quadrant 4. And then add 2 pi. So the measure of the actual angle is 5.902 or 5.903. So this one is about 5.903 radian. Because that it's all the way down in quadrant 4. Okay, so try to set up the cross here. Going this way, quadrant 4. Okay, so magnitude and the direction, so that's what we found. And now let's see, what about the rest of this? So given that vector u, 1, 1, vector v, -1, 1, and vector w, 0, -2, find the following by graphing the vector graphically. Find the magnitude and the directions of the resulting vector, okay? So one thing at a time, let's start it off with this one, so vector u plus v. So we got 1, 1, so let's start out with the individual vector, vector u. And then just label it. And then vector v, -1, 1, going this way. So now, gotta be careful with the way to connect it to find out the resulting vector. So the resultant vector, so this one, a lot of people thought that it's the arrow connected with the arrow, then that's not correct, okay? So got to be very careful with this one. So we just started with the individual vector, okay? So vector v. So the way to do it, so you actually have to trace it with the direction, okay? So you have to follow through the arrow from one vector to another vector. So basically you started off with the initial vector, vector u, so stop here. And then vector v, so this one is going to this way, so vector v. So eventually this one would be the terminal point at 0, 2. So 0, 2 would be the final or the final position. So from the initial to the final. From the initial to the final. So the actual resulting vector would be this one. Okay, so then that would be considered 0, 2. Okay, so 0, 2. So this one basically tells you that the the resulting vector. Okay, so we need to find out the magnitude. So square root of a squared plus b squared. So square root of 0 squared plus 2 squared, which is what? Root 4. So it's 2, the magnitude. And also the directions. So inverse of tangent. So inverse of tangent of b over a. So 2 over 0. So we do know that's undefined. Inverse of tangent is undefined. That means consider pi over 2, 90 degree. And also this one tells you that perpendicular, pi over 2. Okay, so now, and let's take a look at that for b. What about if that's a negative vector u minus vector w? Okay, so let me just erase this one. Just want to get more space. So vector u, again, started with the individual vector. So vector u, once again, it's what? 1, 1. And then w, 0, negative 2, going down this way. Again, just label it vector u, vector w. But now this one is showing that it's minus vector w, so it's negative w. So that means it would be the opposite direction. Opposite direction. So it's going back up. So here's negative w. Again, just want to point out the individual vector. So negative vector w. So it shows the reflection. And then again, so let's do the tracing. So it started with vector u. And then right here at the terminal point, so we want to start it with that negative vector w. So 2 units up. Okay, so eventually the final position would be right here. So connect it from the initial to the final position. Okay, so initial to the final position. Here's the one. And then this point here, so what is that? It's 1, 3. 1, 3. Okay, so that means the resulting vector would be 1, 3. With the little less than, greater than, because that it shows the vector form, the component form. So using the component form to find out the norm or the magnitude of the resulting vector. So square root of 1 squared plus 3 squared, then that would be considered 1 plus 9, which is root 10. And then using this component to find out the angle, theta. So inverse of tangent of theta. Again, it's a non-special ratio, so we have to use the calculator for this. So inverse of tangent of 3 over 1. So inverse of tangent of 3 over 1. So second inverse of tangent, 3 over 1. In radian form, so that one is about 1.249 radian. Okay, 1.249. Right. Okay, so the other one is quite similar. So started with 2w. So 2w, that means 0, negative 4. So 2, 0. Negative 0, negative 2. So going down. So you want to keep going a little bit further because that's 2 times. Right here. So just chase that instead of making the individual vector. So u. So what's u again? So going down this way. Slant it. Up 1 over to the right. Okay, for u. And then plus 2v. So what's 2v? So v, which is negative 1, 1. So then that'll be negative 2. Negative 2 and 2. So negative 2, so 2 units to the left. 2 unit to the left, and then 2 unit up. So 2 unit to the left, 2 unit up. Again, v, which is what? Negative 1, 1. So multiply by 2. So negative 2 and 2. So 2 unit to the left, 2 up. So terminal point. From the initial to the terminal point, so then the final vector, or the resultant vector, then that'd be this one. So which means that it's 0, negative 1. Okay, so again, find out the magnitude. So using the Pythagorean theorem, so we do have square root of 0 squared plus negative 1 quantity squared. So it's 1. And then theta, inverse of tangent of negative 1 over 0. Again, so it looks like this one, it's undefined. Wait a minute, it's 0 comma negative 1, so something wrong. It's not 0 comma negative 1. It's actually negative 1 comma negative 1. Okay, let me fix that. Okay, so got to be very careful with the way to point out the terminal point or the final point. Initials to the final position. Okay, so this one's supposed to be negative 1 comma 1. Magnitude, so square root of negative 1 quantity squared plus negative 1 quantity squared. So root 2. So inverse of tangent of negative 1 over negative 1. So that means obviously third quadrant. So for the radian direction, which is what? 5 power over 4. Okay? And then the next one, so it's quite similar. Sketch the multiple representation of vector 2, 2. So 2, 2 with that the initial position is 0. So 2, 2 is like this. But the things that with different initial positions, so 0, 0. Okay, 2, 2, then that'll be like that. With the initial position 1, 2. So 1, 2. Okay, let's use different color. 2, 2. And that'll be like that. So it started with 1, comma 2, all the way up here, which is what? 3, comma 4. Okay, so this one is all about rise over run. So 2 unit to the right, up 2. Okay, rise over run. From the initial to the terminal. Negative 2, 3. So negative 2, 3. Initial position, all the way up here. Okay, and then it's 2, 2, so 2 unit up, 2 unit to the right. Like that. Okay, so now let's see what else. So decompose the following vector into their component form. So this one is going backward, direction is given, theta, pi over 4. And then vector v, it's 4, the magnitude. So the way to decompose it, so there's a formula for that one, so vector v. So this one, you just put it into the norm of vector v times cosine of pi over 4. And then the other one is just the norm of vector v times sine of pi over 4. Okay, so component form. So cosine of pi over 4, which is what? Root 2 over 2. The norm of vector v, so 4. So 4 times root 2 over 2. Comma, and then 4 times sine of pi over 4, root 2 over 2. So eventually, so this one is 2 root 2, comma, 2 root 2. No need to sketch the graph, just leave it like that, so component form. And this one is just in general, so direction is theta, it's in quadrant 3, and vector u. So this one basically just saying that it's vector u, component form. So a times cosine of theta. Now keep that in mind, direction is theta, it's in quadrant 3. So if quadrant 3, the sign change is always negative, negative. So negative a cosine of theta, comma, negative a times sine of theta. Okay, so make sure that you put in the sign change for that angle. Because we don't know exactly what that is, you know, for the indicator, for the reference angle. So put in the negative. And then what about for that vector v equals 6, direction is 7 pi over 4, similar, so vector v, so 6 times cosine of 7 pi over 4, comma, and then 6 times sine of 7 pi over 4. So again, it shows the horizontal component, the vertical component. So 7 pi over 4, which is root 2 over 2, so 6 times root 2 over 2. Sine of 7 pi over 4, negative root 2 over 2. And then eventually it's 3 root 2, comma, 3 root 2. Negative 3 root 2. Okay, so it's in quadrant 4. Find the direction of the vector. So this one again, theta. So inverse of tangent. So it's 4 over negative 4. So this one is the same as inverse of tangent of 1 over negative 1. So the horizontal component is negative and the vertical component is positive. So negative positive, which means it's in quadrant 2. So the angle would be 3 pi over 4. Okay, so it's pretty straightforward. And then the rest of this, find the following. So 2 times vector u, so do it algebraically. So 2 times vector u, so 3 comma negative 2, plus vector v, so negative 1 comma 4. So 2 times 3, which is what, 6. 2 times negative 2, negative 4, plus vector v. Okay, so basically just combine them. So 6 plus negative 1, so it's 5. Negative 4 plus 4, 0, so 5 comma 0. And then this one, find out the resulting vector first before we find the norm. So v minus, so negative 1, 4, minus 3 times vector w. So 3 times 2 comma 0 in the component form. So negative 1 minus 6, negative 7. And then 4 minus 0, so 4. Okay, so find out the magnitude. So square root of negative 7 quantity square plus 4 quantity square. So 49 plus 16, which is root 65. Okay, so nothing we can do with that root 65, just leave it. Okay. And then the next problem is about the equilibrium. Okay, equilibrium, that means in order to combine all the tension forces, so the final force, it's going to be balanced, so it's all 0. So that means the person is not falling down. Okay, I know it's hanging right here. So this one's a little bit interesting. Okay, so we do have tension 1, tension 2, so 2 different string here. Another one, the person hanging upside down. Okay, so what we can find out, it's that the horizontal component. So started with that, the horizontal component. So it's about the equilibrium. Equilibrium, that means once you combine all those forces, T1 cosine of theta plus T2 cosine of theta, and then plus T3 cosine of theta, well, theta 1, theta 2, theta 3. So it's all considered equilibrium. That means it's all balanced, 0. Same thing happened with the vertical component. So T1 sine of theta 1 plus T2 sine of theta 2 plus T3 sine of theta 3. And that'd be all 0. So let's start it with the horizontal component. So what we have, T1, so this angle here is 45, alternate interior angle. You try to extend this line segment. So T1 times cosine of 45, and then plus, and this one here, so this one looks like it's in quadrant 2, it is. So this angle is also alternate interior compared to this one, 34 degree, but this time is minus T2 cosine of 34 degrees. Well, why it's minus? Because it's in second quadrant. And then all the way down, this one pretty much there's no force because there's no horizontal component. I mean, you can put it in, it's like 120 times cosine of, well, it's the opposite, so it's cosine of 90, or minus 120 cosine of 90. Well, again, why is minus? Because it's upside down, so this one is in between quadrant 3 and quadrant 4. And then it's all 0. So this one can simplify it a little bit, so root 2 over 2 T1 minus, well, this one we don't know what that is, so probably use a calculator for this. Cosine of 34, T2. Minus 120, cosine of 90, that's 0, so that's nothing, so it's all 0. First equation. And then what about for the vertical component? So the vertical one, so then similar, so T1, so T1 times sine of 45. And then this one is in the second quadrant, plus t2 sine of 34. And this time minus, going down. So 120 times sine of 90. So set that equal to 0. So try to simplify this. We do have the second equation. So root 2 over 2, because sine of 45 degree, times t1. And then sine of 34, again, we don't know what that is. So just do that on the calculator. And then minus 120 times sine of 90. Sine of 90, that's 1. So minus 120. Or just set that equal to 120. At 120 on both sides. So we do have the first equation, the second equation. And then for those you might be wondering, how do we solve for this? What is this? It's a linear system equation. Okay, so finish that. So linear system, combine them, subtract. So you do have sine of 34 t2 minus negative cosine of 34 t2, or plus. So set that equal to 0. Set that equal to 120, because 120 minus 0. So once you solve for t2, plug in a number, then you can solve for t1. So you can get those forces for the tension. t1, vector t1, vector t2. Okay, so now what about for this one? So we do have two different vectors of the magnitude. So the norm of v, vector v is 6. The norm of vector u is 10. So they're both acting on point A. So what is the resultant force? So the way to do it, so let's just put it into the standard form. So instead of using the component form, let's put in the I and J standard form. So for vector v, so this one is written as, so norm of v times cosine of 45. But keep that in mind, it's in the second quadrant. You set up the cross here, so negative. I, okay, again, I is just the representation with the horizontal component. It's not the imaginary number. And then plus the norm of v, once again, so sine of 45. Okay, because that's facing up. J, again, indicator for the vertical component. So once we finish things like this, so this one can simplify it a little bit more. So it's negative root 2 over 2 times 6. And then I. And then norm of v, so 6 once again. So sine of 45, root 2 over 2. So times 6j. And then try to simplify it a little bit more. So we do have negative 3 root 2i plus 3 root 2j. And then what about for the vector u? So similar. So put into that this kind of component form. The standard form, excuse me. So this one is just like 10 times cosine of 30 I plus 10 times sine of 30 I, j, excuse me, vertical component. So cosine of 30, root 3 over 2. Sine of 30, 1/2. So what we got here is 5 root 3 I plus 5j. So finally, we do have the result for the vector v, vector u in the I and j standard form. In order to get the resulting vector, the resultant force, so that's just what? Vector u plus vector v. Okay, so basically combine them. So this one, negative 3 root 2 plus 5 root 3 I. And then plus 3 root 2 plus 5 quantity times j. So then that would be the resultant force in the vector form. So u, vector u plus vector v. Okay, so any questions that you have, so make sure that you put into the comment there. So I do like to have some kind of feedback, questions, so, or you can ask me about that during class time. So hopefully you guys liked the video, and I'll see you guys next time. Okay, you guys have a great one. Take care.